Hi, in this video we're going to be working on classifying a solute as a strong electrolyte, weak electrolyte, or non-electrolyte based on its chemical formula as well as its solubility in water. The first step in doing so is to identify the solute as an ionic compound or as a molecular compound. KBr is an ionic compound because it contains potassium ions and bromide ions. Dichloromethane is a molecular compound because it contains only nonmetals that are covalently bonded to each other. The same is also true for methanol. Silver bromide contains a metal ion and a nonmetal ion, so it's also an ionic compound just like KBr. And the last solute, carbon tetrachloride, contains only nonmetals, so it is a molecular compound. Now, electrolytes contain ions that allow a solution to conduct electricity. So because the molecular compounds, in this case, do not break apart to form ions in water, they are classified as non-electrolytes. Later in the course, we'll talk about molecular compounds that do react with water to form ions, but that's coming up in our acids and bases unit. Now, if we take a look at our two ionic compounds, we need to decide how soluble are they in water. And to determine the solubility of an ionic compound, we're first going to find its cation and its anion in our solubility table here. We see that potassium is located here and bromide is located here. Potassium is what's considered a soluble cation with no exceptions. This means that any compound that contains potassium is going to be water soluble. So if we go back up to our table, because it's an ionic compound, it can definitely form ion dipole attractions with water, and it is going to be soluble in water based on solubility rules here, which means it's going to form many ions when it dissolves in solution. So this is going to be a strong electrolyte. Let's go take a look at our silver bromide. For silver bromide, we find our bromine here, or bromide here, and we notice that the silver ion appears as an exception. So, bromide says it's usually soluble in compounds. However, with silver, this would mean the opposite. And so silver bromide, although it can form ion dipole attractions with water, it is largely insoluble. Now, insolubility is not an all or nothing thing, so it will form a few ions. And so the solution it forms is going to be what is referred to as a weak electrolyte because it cannot conduct electrical current very effectively.